Chapter 12, The Risk and the Benefit, What You Can Do. Before the dams were built, the river could speak. People would talk to the river. The trees and the animals could talk. Spirits of the hunters who died on the land walked the riverbanks with spirits of the animals they had killed. These things must have been true because people believed them. After the land was flooded, it was like a killing. They have drowned things that were living. What are they doing to us? What are they doing to our garden? From an interview with Joe Bearskin of the Cree Indians by Bruce De Silva of Hartford Courant. The James Bay Hydroelectric Power Project is the largest construction project ever undertaken by human beings. In the wilds of northern Canada, rivers have been made to flow backwards and thousands of square miles have been flooded. Eventually, the ancestral home of the Cree Indians will be destroyed, all to provide electrical power for the east coast of the United States. The electrical and the electronics industries are constantly expanding their installations and applications. The representatives tell us that if they do not do so, our future standard of living will suffer. The possible health effects of electromagnetic fields have become sufficiently well known that I am frequently asked that what private citizens can do to protect themselves. Generally, this question arises in regards to the proposed construction of a new electric power transmission line, microwave relay station, or other such installation. Unfortunately, the answer is not simple. There are actually several actions that can be taken, all of which are interrelated. First, we need to determine the relative risk associated with our use of electromagnetic energy, personally and collectively, versus the benefits we derive from that use. Second, there are personal actions that individuals may take relating to the devices they use in their homes or offices. Third, there are actions that we may take collectively in concert with our neighbors in regard to a common problem concerning environmental electromagnetic fields. Risk-benefit ratio. We do not live in a risk-free society. Many of the beneficial technological devices we use are potentially dangerous, yet we continue to use them because we believe that the benefit exceeds the risk. The best example is the automobile, which is involved in a great many injuries and deaths each year. However, the structure of our society is such that the majority of citizens feel that a car is essential. Most of us take the usual precautions against accident and injury, and we accept the risk that may occur. In this case, each individual makes his or own risk-benefit analysis. I have found that there are many misconceptions about the health risk associated with electromagnetic fields. The most common is the assumption that such fields arise primarily from external environmental sources. Most people are unaware of the substantial risk associated with the use of many devices in their own homes. It is not logical to fiercely oppose the installation of an electrical power transmission line while using an electric blanket every night. Because our global society runs on electromagnetic energy, there really is no place to hide. Even the most remote mountain valleys, one is exposed to some level of the ubiquitous power frequencies of 50 or 60 hertz, as well as to short-wave radio waves reflected back from the ionosphere. Resolution of the problem of global electromagnetic pollution of the environment will require a concerted international effort. However, as individuals, we have some control of the electromagnetic devices that we use every day. All we need is an understanding of these devices and of the comparable risk associated with each, and a knowledge of how to evaluate the risk in a rational manner. Dose rate considerations, electric razors and electric blankets. The one basic concept that we need to apply is dose rate. For example, the electric razor produces an extremely high strength magnetic field if it is a line operated device, that is, if it is plugged into a wall socket rather than battery operated. I've measured 60 hertz field as high as 200 to 400 milligauss, 1/2 inch away from the cutting edge of a number of different makes of razors. When such a razor is in use, the tissues within a few inches of its surface are exposed to a high magnetic field. Because those 60 hertz fields of only 3 milligauss have been shown to be significantly related to increases in cancer rates, The safety of using this device with a field 100 times greater becomes questionable. However, the dose rate concept must enter the picture. The electric razor is used for just a few minutes once a day, so the total exposure or dose to the user is minimal. Electric blanket fields are somewhat lower, 50 to 100 milligauss, but are still within the danger zone. The electric blanket is applied almost as close to the body surface as the electric razor. Because it is used for several hours at a time, the total administered dose is much higher. Dr. Nancy Wertheimer of the University of Colorado, who publishes the first epidemiological study on power frequency fields, has the incidence of miscarriage is much higher among pregnant women who use electric blankets than those who do not. Of course, this does not mean the other effects, such as developmental defects in the offspring of cancer, are not possible. Miscarriage happens to be an easy and suitable index to use for a preliminary epidemiological study. Obviously, the risk involved in using an electric blanket are quite significant. While using an electric razor is probably safe, I have to say probably because there are, as yet, no data on such short-term exposure to high-strength fields. The comparison of the electric razor and the electric blanket provides a useful example of how one can rationally apply the risk-benefit concept. For both devices, there are obviously alternatives that satisfactorily serve the same function. If one takes the risk of miscarriage seriously, the answer is obvious. Either use ordinary blankets or heat the bed with the electric blanket before retiring and then unplug the blanket. Do not just turn the switch to off. Many electric blankets still produce an electric field if left plugged into the wall socket. The time and effort involved in taking this precaution are minimal and the advantages are obvious. In this instance, the risk-benefit ratio is clearly tilted toward the risk side. In the case of the electric razor, no risk have been identified with its use, even though the field strength is high. However, it too is easily replaced with a safety razor at the cost of a little more time each day. To be perfectly safe and to eliminate even the theoretical risk, one can substitute the safety razor for the electric razor. And because I believe the use of an electric razor may increase the risk of stimulating a melanoma among men with pigmented facial moles, I advised against it in this case. Obviously, risk-benefit analysis becomes much more complicated when the device associated with the risk is difficult or impossible to replace. The automobile is a good example. The ambient field. The ambient field is produced by the local electric power transmission and distribution network, and it is the level of field strength to which we are constantly exposed. This field is present both outside and inside our homes. The popular idea that aluminum siding will shield the interior of the house from electromagnetic fields is incorrect. Unless every piece is carefully bonded together to make a single unit, which is then well grounded, aluminum siding is useless. Shielding a home from the ambient field is a practical impossibility. In urban environments, the ambient field levels often exceed 3 milligauss in the average suburban home. They range from 1 to 3 milligauss, and in rural areas, they are generally less than 1 milligauss. These numbers may be higher depending on the proximity of the home to electric power transmission lines, power line transformers, and so forth. Studies of Wertheimer, Savitz, and others, see Chapter 8, indicate that residential exposure to ambient fields greater in strength than 3 milligauss are significantly related to increase in incidence of childhood cancer. There is good evidence that such fields may also be associated with adult cancers. In risk protection, a factor of 10 is generally applied. In this case, that would drop the theoretically safe level to 0.3 milligauss. Because of practical considerations, I advocate a maximum field strength of 1 milligauss for continuous exposure to 60 Hz fields. This opinion is based on the best evidence currently available. If you are concerned about the strength of the background field in your own home, the only way to determine it is to measure it yourself or have someone else do it for you. When such a measurement is made, all interior field producing devices should be turned off and the measurement device should be held 5 feet away. Manufacturers of appropriate devices are listed in the resources section for this chapter. Because the ambient field is produced outside the home, suggestions on what to do if the field strength in your home exceeds this level will be found later in this chapter in the section on environmental fields. Personal actions. In our everyday activities, we use a number of devices that give off electromagnetic fields. In doing so, we add that field strength to the overall ambient field strength. Remember, however, that the duration of exposure is important. Let's look at some common items in the home from this point of view. Some of what follows may surprise you. Television sets. A television set is one of the most common items in American home, and many people seem to spend a fair number of hours per day in front of it. Most people know that a small amount of ionizing radiation is given off by the screen as X-rays, but few are aware of the amount of and distribution of the non-ionizing electromagnetic radiation from the entire unit. TV set is what we call a broadband radiating source, meaning that it gives off a variety of frequencies from 60 hertz power frequency to radio frequencies in the megahertz range. Since the picture is made up of a separate horizontal lines, each constantly generated left from right, the raster sweep, every TV set contains a unique circuit, the flyback circuit, that returns the line sweep to the left side of the screen at the end of each line. The flyback circuit operates in the VLF range, generally around 17 kilohertz, and this frequency is a major part of the total frequencies given off. When you sit in front of the set, you are being irradiated with a wide range of frequencies, and the strongest components probably being 60 hertz power frequency and the 17 kilohertz flyback frequency. It is a very common misconception that the electromagnetic field is given off only by the screen itself. Actually, the electromagnetic fields are generated within the circuitry of the entire set. Because the box containing the circuitry is transparent to this radiation is given off in all directions from the TV set. The field patterns are not uniform and will differ among different sets, even those with the same screen size. In general, the larger the size of the screen, the stronger the fields, and the further out from the set they will extend. The reason for this is that the size of the screen determines the power at which the circuits must work. Therefore, for large screen televisions, one must sit further away to be exposed to no more than a 1 milligauss field. One thing to keep in mind is that electromagnetic radiation goes through wood and other usual building materials. If the TV set is placed with its back against an inside wall, radiation will be present in the adjoining room just as there were no wall present. Consequently, an infant or child's bed should not be placed against a wall opposite a television set, regardless of the set's field strength. In 1987, Dr. H. Mikołajovics and his colleagues from the Institute of Occupational Medicine in Lodz, Poland, presented the results of a study on TV radiation at a conference called Work with Display Units in Stockholm, Sweden. The researchers had exposed rats to commercial TV sets, which were placed 30 centimeters, about 12 inches from above the animals. The sets were turned on for 4 hours each day. Female rats were exposed for 60 days prior to mating and then for 16 days during pregnancy. It was found that fetal weights were significantly reduced. Male rats were exposed for 35 to 50 days and were then examined. Their testicular weights were found to be significantly reduced. In all animals exposed, concentrations of sodium in the brain cortex, hypothalamus, and midbrain were reduced in below normal levels. Among growing rats of both sexes, growth rates were significantly retarded. In general, exposure to the healthy electromagnetic radiation from television sets slowed growth, reduced the size of the male rat's testicles, and affected the functions of the brain. Personal computers and video display terminals, VDTs. Over the past 10 years, the personal computer has become almost as popular as the TV set in the American home. In offices, it is now commonplace to see literally hundreds of such machines line up in rows. Models manufactured prior to about 1982 produced strong broadband radiation. When these models began to invade the offices adjacent to commercial airports, their interference with control tower operations became apparent. As a result, the FCC enacted rules limiting the amount of radiation computers could produce. And the models manufactured since then have less radiation leakage. However, even today, none of the newer models on the open commercial market is adequately shielded. The radiation pattern is similar to that of the TV set. The major difference in the hazards associated with use is that compared to the TV viewer, the computer operator must ordinarily sit much closer to the device. Almost from the very beginning of the computer revolution, questions were raised about the safety of these devices. These typically were anecdotal accounts of clusters of miscarriages among female computer operators. The term cluster refers to a greater than average incidence of miscarriage among a group of women working at a single location. By anecdotal, we mean that simply that the events occurred spontaneously in the course of business and eventually were reported by the women in question. There were no control groups and no scientific studies were done. Each event was simply handled by a manufacturer's representative appearing in the office, making a few measurements and assuring everyone concerned that the radiation was far below any established safety standard. Any blame for the miscarriages was placed on work stress, poor seating, or bad lighting. But the numbers of such clusters multiplied, and in 1985, Robert DiMatteo, coordinator of occupational health and safety for the Ontario, Canada Public Service Employees Union, collected the data then available and published a book entitled Terminal Shock. He reported the identification of 11 such clusters in the United States and Canada, and he raised the question of whether non-ionizing radiation was the causative agent. In addition to miscarriages, DiMatteo reported a number of other medical conditions associated with computer use. These included birth defects in offspring of operators, cataracts, and other vision problems, disturbances in menstrual cycles, skin rashes, and the general constellations of symptoms associated with chronic stress, such as headache, nausea, sleepiness, and fatigue. Many computer models have attached keyboards, so the operator's head is only about 15 to 18 inches from the screen. Even with models that have detached keyboards, the screen display is most easily read from this distance. Because the strength of the field drops off with the square of the distance, the closer one's head to the machine, the stronger the field. In the mid-1980s, scientific studies were begun in Sweden and the other European countries using animals exposed to computer radiation under controlled conditions. In 1986, doctors Bernard Trabucate and Eva Sekan of the Karolinska Institute and Dr. Lars Erik Paulsen of the Swedish National Institute of Radiation Protection reported that mice exposed to this type of radiation had 5 times the incidence of developmental malformations in their offspring than did control mice. These results were confirmed by a study done the following year by Professor Gunmore Wallander at the Swedish University of Agricultural Science in Uppsala. Despite these scientific findings, each cluster report concerning humans has been discounted by those in authority. It was not until very recently that any large-scale epidemiological study on computer users was completed. In 1988, doctors Marilyn Goldhaber, Michael Pollan, and Robert Hyatt of the Kaiser Permanente Health Group in Oakland, California, reported the results of a study done on a group of 1,583 pregnant women. The results showed that female workers using computers more than 20 hours per week had twice the miscarriage rate of female workers who did similar work but did not use computers. While the number of birth defects in the entire group was too small for accurate statistical analysis, the Kaiser team reported that women using terminals more than 20 hours a week have a 40% increased incidence of miscarriage compared with non-users. In June 1988, despite the laboratory reports in the Kaiser Permanente study, the International Radiation Protection Association still insisted that there are no health hazards associated with radiation or fields from computers or VDTs. I believe that there The evidence belies this optimistic point of view. Obviously, the data indicate that some reproductive risk is associated with the use of personal computers, both at home and in office. Other risks, such as cancer, have as yet not been even studied. Some simple steps can be taken to minimize the risk of using these machines. Using a detachable keyboard and moving the computer proper, a display screen, and any peripheral devices such as disk drives at least 30 inches back from the keyboard will reduce the field at the operator's head to an average of 1 milligauss. Any difficulty in reading the screen at this distance can usually be taken care of by wearing corrective eyeglasses. The advantage of computers have been obvious. The manuscript of this book is being typed on a Macintosh with a detachable keyboard, which is placed 30 inches away from the other components. However, the 30-inch distance is not guaranteed to be safe, and each person must determine his or her own risk-benefit ratio. In the case of female operators using a computer in the average office, I advise that in addition to the 30-inch precaution, as soon as a pregnancy is established, the individual be relieved of computer duties until delivery. Furthermore, in those office situations involving large numbers of computers, attention should be paid to the spacing between the machines in their rows to prevent irradiation of operators in one row from the machines adjacent to them or in the row behind them. The only way to ensure a reasonably safe situation is to actually measure the field pattern and make necessary adjustments. Special caution is required concerning the use of computers in schools. In addition to its obvious advantages in business and personal life, the personal computer is a superb teaching device. The present tendency is to introduce school children to computers at earlier and earlier grade levels. The same precautions as noted above should be definitely be used in this situation. In addition, in view of the present uncertainties about dose rates effects, I considered it prudent to limit computer instruction as to a short a time as possible each day. It has been my observation that many schools are using computers donated to them by people who have upgraded their own machines and given their older models to a local school. Many of these machines, perfectly usable, were manufactured prior to 1983 and give off substantially higher levels of radiation, considering the fact that school children, particularly those in elementary grades, are still growing and have a constant level of cell multiplication with their bodies. It would seem to be a wise precaution to take practical steps to mitigate the field exposure during computer instruction. Unfortunately, because there has been no official recognition of general risk associated with computer use, there are no rules, even for recommendations for their use in schools. Fluorescent lights. Fluorescent lights are much more economical than older incandescent bulbs. They produce many more units of light, lumens, for much longer periods of time at considerable low electric power consumption. As a result, these lights have largely replaced the incandescent bulbs in most offices, schools, and public buildings. Initially, concerns were voiced over possible biological effects from the majority differences in spectral distribution of the light from fluorescent units compared to incandescent bulbs. While the light from each type looks almost identical, it is not. Most of the light output from the fluorescent bulb is in very small areas of the visible spectrum, while the incandescent is much more of a broadband emitter in the visible range. The incandescent light is, therefore, more nearly like natural sunlight. However, there is a basic difference in how the light is produced in each case. The incandescent lamp simply causes a resistive filament to glow when the current at 120 volts and very small amperage is forced through it. The fluorescent lamp has no filament. Instead, a coating of chemical on the interior of the tube is excited to glow when a high voltage discharge is produced within the tube. This requires that the 120 volts of house current be raised to several thousand volts by means of a transformer. The fluorescent light produces much different magnetic fields compared with the incandescent bulb. 2 inches away from 60-watt incandescent bulb, the 60 hertz field is 0.3 milligauss. At 6 inches, the field is 0.05 milligauss, and at 1 foot, the field is lost in the ambient field. A 10-watt fluorescent tube produces a field of 6 milligauss at 2 inches. At 6 inches, the field is 2 milligauss, and 1 foot away, it is 1 milligauss. The 10-watt fluorescent lamp produces a magnetic field at least 20 times greater than the 60-watt incandescent bulb. The circular fluorescent tubes of the type often installed in floor and desk lamps produce a similar field, and the user head is often only a foot away or so. The ceiling fluorescent fixtures with several 20-watt tubes produce a field greater than 1 milligauss near the heads of our office workers below. Some years ago, Dr. John Ott visited my laboratory and presented this data on his behavior of children in schoolrooms. They had fluorescent ceiling fixtures. While his data were very impressive, they included mainly videotapes and stop motion and did not lend themselves well to quantification. I was convinced that behavioral disturbances in classrooms furnished with fluorescent lights were due to the abnormal light output. Considering the average time of exposure, the magnetic fields produced by fluorescent lights can reach dangerous levels. At this time, no studies have been reported or even started on the bioeffects of working in an office or sitting in a schoolroom lighted with multiple banks of overhead fluorescent fixtures. From a risk-benefit point of view, the small amount of momentary savings gained by the use of these lights hardly justifies the potential risk. Electric clocks. An electric clock plugged into a wall socket produces an amazingly high magnetic field because of the small electric motor that runs it. A small bedside alarm clock of this type will produce a field as much as the 5 to 10 milligauss 2 feet away. The bedside table is placed close to the bed so that the sleeper's head is within this range. The dose rate is considerable for the average 8 hours per night. Battery-operated clocks have a negligible field, and I recommend their use as a substitute. Hair dryers. Because hair dryers require high currents to produce heat, they generate very substantial magnetic fields. A 12-watt model will produce 50 milligauss at 6 inches and 10 milligauss at 18 inches from the front end of the dryer. However, the dose rate enters the picture. For the average user, the time of exposure is similar to that of an electric razor. The handheld hairdryer, however, appears to be a hazard for hairdressers who use them repeatedly each day. Most operators tend to have a habitual way of using the hairdryers, and so they repeatedly expose certain portions of their bodies, such as the breast. We have only anecdotal evidence that cancer of the female breast is more common among beauticians than among the general public. No formal epidemiological studies have been done, and when the question of bioeffects is raised, operators' use of many different chemicals in their trade is generally blamed. Electric heaters. Baseboard electric heaters are often installed in homes and offices as either the primary heat source or the backup for some other system. A 4-foot-long baseboard heater produces 23 milligauss at a distance of 6 inches. At 1 foot, the field is 8 milligauss. At 2 feet, it is about 3 milligauss, and it falls to 1 milligauss at 3 feet. In most instances, prolonged exposure occurs at this latter level, and these devices are probably not hazardous under normal circumstances. However, some caution should be observed in locating infants' cribs close to a baseboard heater. Small portable electric heaters that plug into a wall socket produce about the same field intensities, but they are even more dangerous because they may be placed much closer to the body. In recent years, electric heat cables have been installed in ceilings as more efficient means of heating an entire room rather than just the periphery, as in the case of baseboard heaters. In a recent study, Dr. Nancy Wertheimer found that this method produces an average field of about 10 milligauss throughout the entire room. She also determined that the miscarriage rate among pregnant women living in such homes is higher than that of the other women. The study, which has not yet been published, is significant because in this type of installation, body heating cannot in itself be a causal factor for the increased incidence of miscarriages. Increased body heat has been associated with fetal loss, and this possibility had been raised in the case of Wertheimer's electric blanket study. In order for heat to be produced, energy must be expended. In the case of electricity, this requires electric current that is roughly proportional to the heat output. While the magnetic field strength falls off rapidly with distance, any device that electrically produces heat will have a major field strength at short distances from the device. The electric stove, for example, produces 50 milligauss at 18 inches above a 12-inch burner. The field strength drops off in a normal fashion, and the usual exposure to this field is not constant or long-term. Microwave ovens. The microwave oven is another common item in American homes. As with the personal computer, the original models of these ovens were permitted to leak radiation at a higher level than models produced since 1983. However, in the case of the latest models, leakage of 1 microwatt centimeter squared is still permitted. The regulations require only that the oven meet the required level of break leakage when produced at the factory. What happens afterward is up to the consumer. Damage to the gasketing material around the door will markedly increase the level of microwave radiation that leaks from the device when it is in use. Therefore, one should have a microwave oven checked at least once a year. If the door gasket is damaged, the device should not be used until it has been repaired and then rechecked. There are many microwave leakage detectors on the market, but at this time there are no regulations for these devices. As a result, some may work reasonably well, but others may be quite useless. Best thing to do is have a qualified repairman check out the oven each year. In general, these people use meters that are reasonably well calibrated. Problem remains, however, that the safe level of microwave exposure has yet to be determined with any accuracy. Earlier in this book, I listed a consecutive series of studies done over the past 20 years showing that the exposure levels required to produce biological effects have steadily dropped until now they are far below the thermal level. We still do not have any idea of the safe level for continuous exposure. Dr. Arthur Guy's study, described in Chapter 8, indicates that the level must be less than 0.5 milliwatt per square centimeter. We have no idea of the time-dose relationship for intermittent exposure from the microwave oven. At present, I would say that provided that the oven is of quality manufacturer and is checked yearly by a qualified serviceman, it is probably safe for intermittent residential use. But because you shouldn't stand in front of it or the entire time that it is operating, you should give careful consideration to where you locate your microwave. Personal radio transmitters. The use of personal radio transmitting devices has risen sharply over the past decade. Formerly, these devices were licensed and controlled, and they were used primarily by radio amateurs and various public service agencies, such as the police and fire departments. Such devices have now expanded into a host of new unlicensed markets. These include citizens bands radios, CBs, cordless telephones, cellular telephones, home and business security systems, radio-controlled toys, and more. This development has markedly increased the number of persons exposed to significant levels of radio frequencies, or RF. The antenna of most CB radios and cordless telephones are only an inch or two away from the side of the user's head, while the amount of radiated power is limited for these devices. The restrictions are designed to prevent interference with other radio communications, not to protect the user. The only way to communicate with any of these devices is through generating an electromagnetic field. Same field is present in your brain when you press the transmit button on a handheld device. No studies have been done on the incidence of diseases such as brain tumors in people who make use of these transmitters. However, Dr. Samuel Milham of the Washington State Department of Health has reported that the incidence of leukemia is significantly higher among radio amateur operators than among general population. Until appropriate epidemiological studies are done, I advise people to use these devices only when necessary and then for the shortest periods of time possible. How to make your own field measurements. Dr. Edward Long, a general practitioner in Humboldt, Kansas, has discovered an easy, inexpensive, and surprisingly accurate method for measuring the electric fields generated by many devices. Long found the small battery-operated AM radios are very sensitive to these fields. Even though they do not respond to magnetic fields, the electric field is a reasonable index for the magnetic field itself. To check the level of radiation from your TV set, for example, simply turn on an AM radio, tune it to a spot on the dial where you cannot hear a radio station, and then turn the volume up to maximum. Hold the radio about a foot away from the front of the TV and switch the TV on. You will be surprised by the level of noise from the AM radio. If you then move the radio away from the TV, you will reach a distance at which the noise disappears. This is approximately the 1 milligauss level. You will have to rotate the radio at each spot you are measuring in order to get the maximum noise, since the antenna is directional. This method can be used with a number of other devices that give off RF, such as computers, stereos, and so on. It will not work with devices that give off 60 Hz only, such as electric stoves or hair dryers. Most of the accurate monitoring instruments for everything from 60 Hz power frequency to the high frequency microwave ranges are expensive to purchase or rent. Recently, a few relatively inexpensive but sensitive devices for measuring 60 Hz fields only have become available. The reference list for this chapter contains the names and addresses of some suppliers. In this section, I have tried to provide only general guidelines. The standards I apply are mine alone and must be considered provisional in that they are based upon my analysis of the present data and may require revision as more information becomes available. In general, I advise people to think about the devices they currently use and to keep the time-dose relationship and the 1 milligauss recommendation in mind. It is also desirable to consider the safety factor when contemplating the purchase of a device that gives off electromagnetic radiation. Before buying it, ask yourself, do I really need this, and how long will I be exposed to the field it produces? Ambient environmental fields, TV and FM AM radio. In the preceding section, we discussed the 60 Hz ambient fields in the home that is produced by the electric power distribution system. If you can receive television and radio programs in your home, fields of those radio frequencies are also present. While they may be exceedingly small compared to the 60 Hz field, we really do not know what safe level of RF field strength is for continuous exposure. This may appear to be absurd. After all, such communication is the norm in developed countries. We have been using it for a long time, you may think, and nothing has happened. Neither is exactly true. The extensive use of radio communication has occurred only in the past few decades. I am old enough to remember the old days of radio in the 1920s and the early 1930s when the usual receiver was a crystal set and they only had a handful of AM radio stations that could be heard. The remarkable expansion of this modality has occurred just since World War II, with the advent of commercial television and FM radio transmissions. The belief that nothing untoward has happened is based upon the concept that if these fields were truly harmful, they would produce a unique and very evident disease. For instance, if everyone's hair had turned green soon after the start of FM transmissions, the link would be obvious. The problem, as we have already noted, is that the disease patterns resulting from exposure to man-made electromagnetic fields are in general not new. Instead, for the most part, they are increases in pre-existing disease types, which may be attributed to many other causative factors such as toxic chemicals. Until a sufficient number of controlled epidemiological studies have been done, we simply will not know the true extent of hazard. In Chapter 8, I mentioned the work done by Dr. William Morton in early 1970s on the relationship between FM radiation and leukemia in Portland, Oregon. He reported that those neighborhoods with the largest levels of FM radiation also had the highest rates of leukemia. When Morton did his study, the results were considered so outlandish that the EPA, which had funded the study, ignored it. However, those results were confirmed by the 1986 study conducted by Drs. Bruce Anderson and Alden Henderson in Honolulu. Unfortunately, except for the FCC's establishment of new rules for field strength in the areas around the bases of new broadcast towers, little attention has been paid to either of these two studies. No federal guidelines have been provided for the general population, and the EPA recently announced that it will not issue any in time in the immediate future. It is therefore up to the individuals to determine whether they or their children are at possible risk from such radiation in their own homes or schools. Lacking the necessary hard drives, the best you can do is determine how close your home is to any radiating source. This obvious question is, how close is too close? Unfortunately, the lack of data makes it impossible to provide a firm answer. When dealing with higher power sources such as commercial TV or FM stations, I believe that it may be reasonably safe. You should be about a half a mile away unless there is a major obstacle such as a hill between you and the tower. This is, at best, a very rough guess based upon the preliminary data from the two studies above. I must emphasize that people living closer than this to a tower may not be at a risk. However, it appears obvious that if your home is located within 100 feet of such a tower, a real risk is probably present, particularly for children. In order to make an informed evaluation of the potential risk, you must know what to look for, because it is the nature of TV, FM, and microwave to radiate as line of sight waves as straight lines from the transmitter. The tendency is to place the towers on the highest ground available, thus expanding the area within which the signals can be received. It is therefore common to see a number of towers clustered together on hilltops around cities or on the tops of highest buildings in the cities. These include TV, FM, and communication towers for local police and fire departments, public service agencies, paging services, and so on. Even though each antenna is transmitting at a different frequency, the total field that results in the additive one from all of the transmitters and the local field will be very high. Some years ago, the EPA surveyed the entire United States and identified 200 hotspots of high field strength caused by such clustering of antennas. Because of the lack of regulations, it is not unusual to find residential developments located in and around such hotspots. AM radio stations, on the other hand, are most often located in valleys because their signals are of a different type and do not operate as line of sight waves. Because the majority of the AM stations were built some years ago, housing developments, schools, and public buildings have frequently been built in proximity to them. While the antennas of the towers come in a variety of styles, the fields given off by TV, FM, and AM radio and communication stations are quite similar in that they are all radiated in a 360-degree pattern from the tower site. AM radio stations have several towers located about 100 feet apart. Their signals are of low enough frequency that they will follow the contours of the ground. Therefore, hills are no obstacle to receive their signals. AM radio waves that extend upward at an angle are reflected back off the ionosphere at the same angle. In this way, the signal may be heard several thousand miles away. This is the technique used for shortwave radio transmission. TV and FM waves that go up are not reflected off the ionosphere, but simply keep going out into space. Very rarely, a solar storm will increase the energy in the ionosphere, and the high frequency waves will be reflected back to Earth. Also, to spot many thousands of miles away from where the signal originated. Microwaves. Following World War II, most of the original long-distance telephone cables were replaced with microwave links. Fortunately, this use is now being phased out in favor of laser light among the buried fiber optic cables. Not only is this new technology more efficient, but it also appears quite safe because little electromagnetic energy is given off by such cables. However, the changeover has proceeded slowly, and only a small portion of the national long-distance microwave network has been replaced. At the same time, microwave usage by various public service agencies, utilities, and commercial establishments is growing. When questions of safety are raised over an existing or proposed microwave installation, the public is assured that the radiation is given off as a narrow or pencil-like beam directly toward the receiving antenna, and that nothing else is irradiated. The fact is that this is what the engineers wish it were like, because that would be the most efficient use of power. In actuality, every microwave antenna emits a primary beam with accompanying unavoidable side lobes, which spread the radiation around a 180-degree arc from the dish. Microwave antennas also come in a variety of shapes and sizes, and many are often clustered on a single tower. When considering the possible hazards of microwaves and radio frequency sources of all types, take into account not only your distance away from any such installation, but also the fact that any specific location may be radiated by several transmitters. It is therefore necessary to measure the field from each source and add them together to arrive at the total field strength at your location. It is my personal opinion that any total field strength above 0.1 milliwatts per square centimeter is likely to be hazardous for residential exposure. The only way to determine whether your home falls within this range is to have measurements taken or to try to do it yourself with rented microwave and RF monitors. Even then, lacking any established federal guidelines, it would be practically impossible to have an existing installation shut down or moved unless the measured levels exceed the American National Standards Institute guideline of 5 microwaves centimeter squared, a rather unlikely occurrence. In the case of a proposed installation, however, it is often possible to make a good case to local zoning authorities on potential health hazards. This requires organized action by the citizens who are potentially affected. If you are living near satellite dishes designed only to receive television programming from satellites, you need not be concerned. These are passive devices and do not give off electromagnetic energy. Satellite transmitting dishes, however, which are from 50 to 80 feet in diameter, radiate strong fields. The long-term radio frequency microwave solution. The problem of RF contamination of the environment must be addressed at the federal level. Some states and municipalities have already begun to set local standards based on the potential for health effects. Since standards vary considerably from state to state, a patchwork effect is beginning to appear. As a result, on a federal level, many of these standards are unenforceable. In order for us to have enforceable and realistic standards, the federal government must be set uniform standards based upon solid scientific data. Unfortunately, such data are simply not available at this time. Therefore, I oppose the setting of any standard on the basis that it would convey a false sense of security. Assuming that the federal government will take up this problem in realistic fashion, what will happen if the hazard level falls below, which is already present in most metropolitan areas? Will we have to turn off our TVs? Not at all. Once the hazard level has been determined, the engineering solutions are not difficult. At present, the FCC limits the radiated signal power from every TV, FM, and radio station to prevent interference with other stations. Once the need to reduce the total ambient levels has been determined, average signal power may be reduced to meet that requirement. Additional steps may include limiting times of operations and using low power repeater stations to extend areas of coverage. The clustering of TV towers can be replaced with direct satellite broadcast. In this technique, the programming is transmitted by satellite to a wide geographic area with the very low average power levels at the ground surface. At present, this method is in use in many rural areas where tower installations would not be economical. There are other steps that can be taken, and there is no need to turn off our public communication systems in order to make them safe. The long-term electric power solution. In the case of transmission lines and their auxiliaries, such as substations and transformers, we now have the action level of a 3 milligauss magnetic field upon which to base a risk assessment. If you are living in close proximity to an established transmission line and measurements inside your home average 10 milligauss, what can you do? If you have concluded through a risk-benefit determination that you and your family are at risk, the answer is simple but unpleasant. Your only option is to move. As with microwave and radio transmitter installations, legal actions against established transmission lines are costly, prolonged, and fruitless. However, concerted action only often succeed in preventing the installation of a proposed line. Nevertheless, be aware that such an effort is still expensive in time, effort, and money. Utility companies will defend proposed lines on two grounds. First, they claim that there is no compelling evidence for health hazards from transmission lines. Second, they say there is a pressing need for the line to supply more electrical power. They will claim that if it is not built, the economy will suffer and insufficient power will lead to burnouts or blackouts. Both claims will be easily refuted, the first on the basis of the data contained in Chapter 8 and the second on the basis of the long-term solution to the problem. Do we really need more electric power? While utility companies are regulated by each state, there are still businesses and they are continually attempting to sell more power and justify the building of more generating plants and transmission lines. The record shows that they have consistently overestimated the future requirements for electrical power. Robert C. Marley, Special Assistant to the Deputy Assistant Secretary for Conservation in the U.S. Department of Energy, has studied trends in the industrial use of energy since 1973. In 1984, he reported, during the 10 years following the 1973 Arab oil embargo, significant changes took place in U.S. energy consumption. After decades of steady growth, annual demand for energy leveled off and began to decline. Total energy consumption in 1983 was less than that in 1973, despite economic growth over this same period averaging 2.5% per year. Prior to 1973, the utilities were predicting a 30% increase in demand by 1983. This obviously did not occur. Nevertheless, the economy continued to grow. Marley's point was that the growing availability of cheap energy in 1984 could again lead to increased consumption, which would actually be unnecessary and inefficient. 2 years later, Marley's concerns became fact. The utilities again began issuing forecasts of impending doom if the new construction was not begun immediately. In addressing this issue, Dr. Amory Levins of the Rocky Mountain Institute in Old Snowmass, Colorado, showed that the increasing efficiency of the utilization of electrical power could easily produce the equivalent of the increased generating capacity and at a much lower cost. To put this situation more bluntly, in briefing on nuclear power issued in 1988, the Union of Concerned Scientists stated, "Today, this U.S. is overflowing with excess electricity. In 1985, we had a reserve of nearly 52%. That means the nation had much more electricity than it needed to meet its peak summer demand, as well as an adequate margin for emergencies. Utilities had many more large power plants than necessary to provide reliable electric service. It is obvious that at this time, we really do not need more generating power plants and transmission lines. All of the above analysis were concerned only with the efficiency of operating of the U.S. energy system. None took into account any possible health risks to general population from 60 hertz power systems. When this factor is included in the analysis, the conclusion becomes even more obvious and the requirement for conservation and increased efficiency even more pressing. I am not advocating the dismantling of electrical power supply system and its replacement with kerosene lamps. What I do advocate is a change in the basic structure of the entire system. The concept of a single large generating power plant supplying a wide area with electric power via long transmission line arose when electrical power first began to be generated. At that time, many small independent systems were set up, each supplying relatively small areas. The motivation for a concentrated system was with the realization that it was possible to increase company profits by acquiring these smaller systems and supplying their combined area from a single area, large generating plant. Since then, the concentrated system technique has dominated the entire industry. When tied together into a nationwide transmission power grid, the concentrated system has some important defects. First, it is a fragile system. Failure of a single component can cause the crash of large portions of the system, with the subsequent blackouts lasting for several days. Second, as the trend towards greater and greater concentration of the generating plants grows, the need for supervoltage transmission lines increase. 760 kilovolt lines are already in use and 1 million volt lines are planned. The fields produced by such lines are proportionally larger in extent and higher in strength than Their construction will result in the exposure of greater numbers of population to potentially harmful levels of electromagnetic radiation. Whether these defects could be obviated by a restructuring of the system into a dispersed type, in which single large generating plants are replaced by multiple smaller ones. The smaller plants could be located to take advantage of the multiple generating sources such as a water, wind, and the sun, in addition to the standard fuels. The transmission lines from each small plant would supply a smaller area and would require much lower voltages and currents. Each generating plant and supplied area would be tied to its neighbors in such a fashion that power could be supplied from neighboring sources in the event of a shortage or outage. In addition to producing much less hazardous fields, a dispersed system would be economically competitive with a concentrated system and that at the same time would be less susceptible to large-scale blackouts. The time required to accomplish the conversion from the concentrated to the dispersed systems would be considerable, and such a change would be fiercely contested by the utilities themselves. Nevertheless, in consideration of the percentage of the population that may be already at risk from the 60 hertz electric power systems, the problem must be addressed as a national objective. If advances in photoelectric technology continue, the above steps may turn out to be unnecessary. In photoelectric technology, sunlight is converted directly into electric power by collectors. In appropriate locations with abundant sunlight, efficient collectors could theoretically supply all the power for a single residence. At present, the efficiency of these devices have risen to slightly more than 10%. If it can be increased to 15%, the photoelectric system will become economically competitive with the commercial power systems. Risk-benefit analysis, industry view, and citizen action. The idea that we can live in a totally risk-free world is not only unrealistic, but unattainable as well. There are very few things in our society that are solely beneficial or solely devoid of benefit. Everything is some shade of gray, and the best that we can do is minimize our personal risk consistent with benefits. The sticking point comes when risk benefit decisions have to be made on community or national levels. These decisions are generally not directly in the hands of citizens who would be exposed to the risk. Instead, they fall to various governmental bodies. When the installations are proposed by private industries, utilities, manufacturers, biotechnology companies, and so on, the question of risk versus benefits is raised early on, often by the industry itself. The usual statement issued is that the benefits far outweigh the minimal risk involved. Since risk benefit analysis are made on the basis of scientific evidence, scientists inevitably enter the process. There are two types of scientists who become involved in the issue of electromagnetic field health risk. First are experts on the biological effects of the electromagnetic fields who often take diametrically opposite views. Some emphatically insist that no harmful effects can occur, while others are equally adamant that real hazards already exist. Less common, but increasing in number, are the experts on the risk-benefit analysis itself. These people are not necessarily directly involved with the specific subject, but they consider themselves able to evaluate the risk-benefit ratio for any question. They do this on the basis of the statistical computerized analysis of the scientific literature, arriving at the numerical data that compare the risk in question with other risk-producing situations. For example, these scientists can calculate the number of expected deaths from cancer in a population exposed to a 60 hertz electric power transmission line, compare that with the expected number of deaths in the same population from cigarette smoking, and declare that the transmission line poses less hazard. While all this may look very scientific, I believe it is nonsense. The basic defect in this type of analysis is that present scientific data are accepted as the final word, never to be revised or updated. I have yet to see a scientific question over which there was no difference of opinion among reputable scientists. Such differences may be honest, motivated by some uncertain about the data or by a valid but different outlook. When this occurs, the actual decision-making authorities have a difficult time. There is a well-known story about a Senate hearing during which such a situation arose. The senator was overheard to whisper to a colleague, "What am I supposed to do? Count the Nobel Prize winners on each side and say that the one with the most wins?" Unfortunately, expressed differences of scientific opinion are not always so noble. Scientists are, after all, human beings, and some can be tempted to shade their opinions for certain considerations. It is quite possible to slant a presentation by ignoring positive data indicating risk, or to require of such data a much higher standard of scientific rigor than for negative data. The citizen groups in opposition to the planned construction generally lack the resources to hire scientific evidence who share their views. So corrective measures are urgently needed in this entire process, not only in the regard to electromagnetic field producing installations, but also to the entire range of the technological innovations that impinge on the general environment. Until appropriate measures are taken by the responsible federal agencies, it is up to individual citizens to make their own risk benefit analysis and to take those steps that they themselves feel are prudent to protect their health and the health of their children. The hidden hand on the switch, military uses of the electromagnetic spectrum. The military group provides powerful incentives for releasing forbidden impulses, inducing the soldier to try out formerly inhibited acts which he originally regarded as morally repugnant. I.L. Janis, as quoted in the Oxford Companion to the Mind, edited by Richard L. Gregory. The current military strategy of the United States does not rest on nuclear weapons or elite strike forces, but is instead based on a doctrine known as C3I for command, control, communications, and intelligence. Through C3I, the relative strength of our forces against those of the Soviet Union is constantly assessed, and the intents of the Soviets to deploy and use their forces against us is determined. C3I provides intelligence to accomplish this task, as well as the means to communicate with and control our forces and to command them to counter-perceive or actual threats. The overall intent of this military doctrine is to know instantaneously and at all times the exact status of our forces and those of a particular enemy. Weapon systems are simply the instruments that are used to deter or respond to an attack. Our total military system has become an analog of living organism, constantly sensing its environment, integrating information and reaching decisions, and then acting on those decisions by using the appropriate weapon systems. The central nervous system of our nation's global military organism is based on the information carrying out electrical impulses that are transmitted by electromagnetic fields. Its sensory organs are microwave scanners, satellites, and sophisticated devices designed to listen to an enemy's radio transmission. Instead of nerves, it uses radio communications with frequencies ranging from ELF to super high microwaves. The muscles of this military organism range from the ground troops to nuclear missile systems. There are a number of brains in the organism located both in the continental United States and in various overseas locations. The organism is capable of operating on its own with only the theoretical restraint of approval from the White House. Every aspect of C3I depends upon the unrestricted use of all frequencies of the electromagnetic spectrum at unlimited power densities. Historical development. This military doctrine slowly evolved following the end of World War II and was shaped by two factors. The first was the practical experience of using electromagnetic fields for communications and sensing, primarily radar, during the Korean War. The second factor was the later availability of transitorized equipment and the development of exotic electronic sensing and communication systems, which occurred during the Vietnam conflict. Vietnam was the proving ground for the basic concepts of C3I that has been characterized as the first all-electronic war. A number of advanced technologies were tested. For example, long-range reconnaissance patrols operating far behind Viet Cong lines were equipped with solar-powered high-frequency radios. These devices enabled members of a patrol to communicate with one another via military satellites 200 miles up in space and to be instantaneous communication with the White House. Following the Vietnam War, the doctrine of C3I matured into its present global scale based on maximum utilization of electromagnetic energy. The only restriction ever placed on this military doctrine since its inception in the 40s was derived from the period of time immediately following World War II and during the beginning of the Cold War. In the early 1950s, the Department of Defense recognized the need for some sort of safe exposure standard for microwaves. This led directly to the establishment of the Tri-Services program based at the Rome Air Development Center in Rome, New York, which was given the task of determining the standard. However, even before the Tri-Services program began, military eagerly adopted the concept that only thermal effects were damaging to living organisms. Based solely on calculation, the magic figure of 10 milliwatts per square centimeter was adopted by the Air Force as the standard for safe exposure. Subsequently, the thermal effects concept was dominated policy decisions to the complete exclusion of non-thermal bioeffects. While the 10 microwatts, while the 10 microwaves centimeters squared standard was limited to microwave frequencies, the thermal concept was extended to all other parts of the electromagnetic spectrum, unless it heated tissue. Electromagnetic radiation was thought to be harmless, so there was no limits placed upon exposure to frequencies below microwave. The conspiracy. The military organism was designed on the 10 microwatts standard, and once in place, it had to be defended against the possibility of non-thermal bioeffects. The recognition of validation of these effects would mean the collapse of the total organism and the death of C3I. My work on the electrical control systems and the bioeffects of electromagnetic fields involved me in this controversy early in the 1970s. It quickly became apparent to me that evidence for non-thermal effects was viewed as a threat to national security. Safety was not a consideration because the military mindset of the time held that despite the lack of actual hostilities, we were in a state of war with the Soviet Union. It was believed that our ability to prevail in that conflict required the virtually unlimited use of electromagnetic energy for all four facets of the C3I doctrine. This view led to the policy of denying any non-thermal effects from any electromagnetic usage, whether military or civilian. To accomplish this policy objective, several specific actions were taken as follows. Control over the scientific establishment was maintained by allocating research funds in such a way as to ensure that only approved projects, that is, projects that would not challenge the thermal effects standard, would be undertaken. Further, the natural reactionary tendency of science was capitalized upon by enlisting the support of prominent members of the engineering and biological professions. In some instances, scientists were told that non-thermal effects did occur, but that national security objectives required that they be exceptionally well established in before they became public knowledge. Many scientists' goals were subverted by unlimited grant funding from the military and by easy access to the scientific nature. The formal scientific establishments of the United States were mobilized. When serious challenges to the thermal effects standard were raised publicly, eminent scientific boards, associations, or foundations were provided with lucrative contracts to evaluate the state of knowledge of bioeffects of electromagnetic fields. These investigations resulted in the production of voluminous reports. All of these reports shared certain characteristics. Scientific data indicated non-thermal bioeffects were either ignored or subjected to extensive and destructive review. Those examined were required to have much higher standards of possible validity than reports indicating no such bioeffects. Scientists who reported the existence of non-thermal bioeffects were ridiculed and were portrayed as being outside of the mainstream. Actual disinformation was utilized to create a false impression. For example, while a statement such as there is no evidence for any effects of pulsed magnetic fields on humans would have been literally true, it would have ignored the many reports of such effects on laboratory animals and the fact that no actual test had been conducted on humans. It was common practice to include an executive summary with the massive report. These summaries were never reflected in the data and were actually hidden in the full report. A group of the manufactured experts were produced to serve as spokesmen and expert witnesses. Scientists who persisted in publicity raising the issue of harmful effects from any portion of the electromagnetic spectrum were discredited and their research grants were taken away. Despite the applications of these measures, the question of harmful effects did not go away, but instead increased intensity. The The position of the government has thus been forced to change. The government's initial complete denial of any non-thermal effects was followed by acceptance of some non-thermal effects, although these were characterized as being unimportant and transient. At present, the official position that while there are some non-thermal effects that may be harmful, further study is required before any setting action is taken. While the military was vigorously denying the very existence of bioeffects from electromagnetic field exposure, such bioeffects were actually being explored as potential weapons. Weapons with the enormous advantage of being totally silent and imperceptible. The EMP concept has been extended through the development of devices that generate EMP pulses without the need for nuclear explosions. Such devices could be deployed for use against enemy command and control centers or against aircraft in order to produce failure of electronic equipment. A derivative of this program is HPM, high-powered pulsed microwave, a system producing intense, extremely short pulses of microwave. Several types ranging in frequency from 1200 megahertz to 35 gigahertz with powers up to 1000 megawatts are being tested. These are also being considered for potential use as weapons against human beings. As a recent report derived from the testing program of the Microwave Research Department at the Walter Reed Army Institute of Research states microwave energy is in the range of 1 to 5 gigahertz, a military important range, penetrates all organ systems of the body and thus puts all organ systems at risk. Effects on the central nervous system are considered very important. The testing program begun in 1986 is divided into 4 parts: prompt debilitation effects, prompt stimulation through auditory effects, work interference stoppage effects, effects on stimulus controlled behavior. The report goes on to state microwave pulses appear to couple the central nervous system and produce stimulation similar to electrical stimulation unrelated to heat. It appears that high HPM or high powered pulsed microwave is capable of altering behavior in the same fashion as Delgado's electrical stimulation. The production of cognitive and behavioral alterations by high-powered pulsed microwave is a sledgehammer effect in comparison to the subtle alterations produced by ELF fields. According to a 1982 Air Force review of biotechnology, ELF has a number of potential military uses, including dealing with terrorist groups, crowd control, controlling breaches and security, and military installations, and anti-personnel techniques in tactical warfare. The same report states electromagnetic systems would be used to produce mild to severe physiological disruption or perceptual distortion or disorientation. They are silent and countermeasures to them may be difficult to develop. A new class of weapons based on electromagnetic fields has been added to the muscles of the military organism. The C3I doctrine is still growing and expanding. It would appear that the military may yet be able to completely control the minds of civilian population. I have made no attempt here to review in any detail the relationship between military considerations and the hazards of man-made electromagnetic fields. This complex and dangerous situation lies outside the scope of this book, except for an indication of how the political policies derived from it have effectively hampered the public recognition of the standards of the hazards. In my opinion, the military establishment still believes that the survival of the military organism is worth the sacrifice of the lives and the health of large segments of the American population. The end.